The first technique under Mac that we shall be studying is SDM. SDM is nothing but space division multiplexing. Okay. Now space division multiple access or spatial division multiple access is a technique which is MIMO, that is multiple input and multiple output. So when I talk with regard to MIMO, we have multiple, signals that are going to get handled. Okay, in space division is what my MIMO is talking about, and that is a particular architecture widely used in wireless and satellite communication. So when I talk with regard to space division multiple access, I have what I the architecture that is employed is multiple input and multiple output. Let us have a look at this particular figure wherein you can see that an antenna is being employed and you have various spaces that are being designed. Okay, so this particular antenna is covering a wide range of space and a separate subspace is being allocated for each of the user. So they are doing what? The antenna is doing the entire work of space assigning to specific user. Now what are the features with regard to SDMA are all users can communicate at the same time using same channel. Okay, so as we said in SDM, that is space division multiplexing also, that it would not be the one that would be utilized alone, but would be used in conjunction with any of the rest 3 dimensions or rest 3 techniques. So with SDMA you could have even Fdma, or you could have Cdma, or you could have Tdma. Now SDMA is completely free from interference. Why we are saying? Because we have separate spaces that are assigned. A single satellite can communicate with more satellite receivers of the same frequency. So we are saying that because it is used in wireless and most prominently in satellite communication, then how exactly space division is happening? For that reason they are saying that with MIMO architecture, multiple satellites are able to communicate or send or receive information. Now the directional spot beam antennas are used, and hence the base station in SDMA can track a moving user. Now when you talk with regard to track a moving user, we know that one specific user would not be stationed for lifetime at one place. The user would be moving from one particular location to another, and how exactly this individual tracking is happening is with regard to the spot beam antennas that are there in place. Next is it controls the radiated energy for each user in space. Okay, so SDM is one of the technology multiple access technique that is bifurcating the space for the multiple users. Okay, and bifurcating the space in such a way that there is no interference when multiple users are interacting or using the same transmission medium. Now when I say different space, a typical application that would be involved would be assigning an optimal base station. Okay, so a optimal base station to a mobile phone user. So here comes a concept about what we call as cells, and then we have a specific cell is nothing but a specific region wherein we are as a mobile stations or as mobile users are connected to a specific tower. Okay, how we have in our local areas that this particular tower is there, that is would be handling the calls that are being initiated by us in that way. Okay, now what it says is that the next part is the mobile phone may receive several base stations with different quality. Definitely several base stations would be there. Okay, and several base stations with regard to different telecom providers would be there, and they would be doing what? They would be sending and receiving the data. Now what is the SDMA or what is the MAC algorithm would be that we need to decide which base station is the best for a specific mobile user, taking into account FDM, TDM, CDM, depending on or depending on the SDM technique is being applied. Okay, now when I say depending on the SDM technique is being applied, why? Because multiple times he said that SDMA would not be the technique that would be utilized alone, but it would be utilized in conjunction of what here? Rest of the three dimension. Now what exactly SDM does is it forms the cells and sectorized antennas which constitute the infrastructure implementing SDM. Okay, so basically when I say that a user is there and a user is able to communicate with another user, okay, how exactly this particular communication is being taken into consideration or is being implemented is through the base station, and there would be multiple base stations. Say for example this is one region, then there would be multiple base stations. So with SDM plus any of the technique, multiple access technique, this secure communication, this without interference communication is being employed. So that is what your space division multiple access is talking about. After SDMA, the next technique is Fdma, that is frequency division multiplexing or multiple technique, not multiplexing, multiple technique. Now very important here, we would be even understanding how and what are the differences when we talk with regard to multiple access and multiplexing. Now in frequency division multiple access, the available bandwidth is divided into frequency bands. Okay, we can see over here that there are multiple users, okay, and each user is allocated its own frequency band. So in order for the demonstration we have the color code. So this is for this particular user, this is for this particular user, this part is for this, and the dark blue part is for this. So each user is being assigned with what? A different frequency band, and there is what? One listener who's going to receive or who's going to listen to the communication. Now each station is allocated a band to send its data. Okay, now this band would be utilized in order to send the data. In other words, each band is reserved for specific station and it belongs to that station all the time. Definitely when we say color codes, when we are understanding this example by the color code frequencies that are used, I know that the purple color would be utilized only by this user and none of the other users. So it is dedicated to this specific user. Each station also uses a bandpass filter to confine the transmitter frequencies. To prevent station interferences, the allocated bands are separated from one another by small guard bands. Okay, so here also the concept about guard bands are introduced. Why are guard bands introduced? Because there should not be interference with another frequency ranges or another transmitting frequencies. Now when we say are being filtered out, so filtered out for what? That there is no mixing of two frequencies that are happening. Now over here the guard band is not shown, but imagine a particular space, frequency space that is free, that is restricting the two bands, that is the purple and the blue band, that is for that band to interfere with one another. When I say interfere, to mix with one another. So that is what is frequency division multiple access is about. Now the next important part is how exactly Fdma is different from FDM. Now this is very important. Fdma is an access method in the data link layer. So we all know about what? We all know about your OSI model. We know that we have 7 layers, okay, starting from physical layer to the application layer, and data link layer is the second layer in the OSI model from bottom to top. So it is an access method in which layer? It is an access method in a data link layer. Whereas if when I talk with regard to frequency division multiplexing, it is a physical layer technique that combines loads from low bandwidth channels and transmit them by using a high bandwidth channel. So this is what? This is working on the physical layer, whereas multiple access technique is working on what? Here, data link layer. The data link layer in each station tells its physical layer to make a bandpass signal from the data passed to it. So this multiple access is telling what? That bandpass signal with a restricted frequency, okay, This is the restricted frequency range, say for example f1 to f2. Now this particular piece of information is being passed from DLL, that is data link layer, to what, your physical layer. The signal must be created in allocated band. Okay, that is what the responsibility of FDMA is. There is no physical multiplexer at the physical layer. The channels that are combined are low pass. The multiplexer modulates the signal, combines them and creates a band pass signal. Next is the signals created at each stations are automatically band pass filtered. They are mixed when they are sent to a common channel. And the last point says over here, the bandwidth of each channel is shifted by the multiplexer. So this is how the FDMA differs with what here multiplexing, that is FDM technique. Okay, now what is being referred to as a signal must be created in allocated band? Because when we say frequency division multiple access as one of the transmitter in a particular situation, I know what are my frequency ranges in which I need to transmit. So the signal has to get created in that particular frequency range only. Okay, in that particular frequency range the signal has to get created. For that reason it is said that it is being the automatically band pass filtered. It does not exceed within that range. Okay, so if f1 to f2 is what my frequency range is, I would be creating my data within that particular frequency range only. Okay, now when I'm talking with regard to frequency division multiplexing techniques, over here in the second we are saying that multiplexer is doing what? It is modulating the signal and then combining them into one. So this is what the key difference when we talk with regard to multiple access and when we talk with regard to multiplexing is all about. The next technique is that of TDMA, that is time division multiple access. Now in time division multiple access, the station shares the bandwidth of the channel in time. So how frequency were getting utilized in frequency division multiple access and how space was getting utilized in space division multiple access. In that same way we have what? We have time now that is getting as a dimension utilized in what? My time division multiple access. So time slots would be given for individual transmitter. Each station is allocated a time slot during which it can send the data. Okay, so each time slot, and within that particular time slot only that data would be received by the receiver. Each station transmits its data in its assigned time slot. Okay, when you have been given a particular time slot, that particular receiver would be synchronized or would be receiving the data in that specific time slot only. The main problem with TDMA lies in achieving synchronization between different stations. Each station needs to know the beginning of its slot and the location of its slots. Now, over here, when we talk with regard to synchronization, we have the two aspects of synchronization. Synchronization amongst different senders. So when I talk with regard to this particular example, this is the listener. These are the time slot. Now you can see the division that is happening is with regard to the time domain and not with regard to the frequency domain. So when I say that multiple senders are going to send the data to the receiver, okay, so there should be a precise synchronization between the time clocks of the senders too. Not only between the senders, there should be even a precise synchronization between a sender and a receiver. So the senders should not overlap. For that reason, there should be a synchronization between amongst the senders, and the receiver should be able to receive the exact data. For that reason, there should be a synchronization between the receiver and the sender too. So that is what very essential when we talk with regard to TDMA. This may be difficult because of the propagation delays introduced in the system. Now, there could be some problems when we talk with regard to synchronization, and the problem is nothing but your propagation delays. That is, if the stations are spread over a larger area. To compensate for others, for the delays, we can insert guard times. Now, why are we inserting guard times? Again, what are the guard times? As we got introduced to guard times in Sdma, we got introduced into guard times in Fdma. So basically, whenever multiple transmitters are there and when we want the transmitters, okay, data should not, cause the transmission should not cause interference with one another, we do what? We give some kind of break between the two transmitters. So in order to avoid interference, when we talk with regard to your FDMA, we have what? We have adjacent channel interferences that were happening. When we talk with regard to TDMA, we have co-channel interferences that are happening. So in order to avoid, basically when we talk with regard to guard spaces, they are the element that are introduced to avoid interferences between the channel or amongst the various transmitting channels. So guard spaces are there, so that even if the propagation delay is there, the guard space is there that is going to fill up that particular problem. Now, synchronization is normally accomplished by having some synchronization bits. Now, when we talk that synchronization is so essential, how is that achieved? By synchronization bits, normally referred to as preamble bits at beginning of each slot. So say for example, when we say that multiple senders or the transmitters are ready, but this is the chance, this particular sender's chance is there to transmit the data, the time slot, his time slot is there in order to transmit the data, so that for other transmitters to get synchronized with this particular sender's clock timing, he will be sending what? At the beginning of the transmission, he would be sending the synchronization bits. And that particular synchronization bits, okay, normally referred to as preamble bits, would be there at beginning of each time slot for each respective individual or each respective transmitter that is going to transmit the data. Now, the next part with regard to TDMAs, we shall be having a look how TDMA and TDM are, what the concept about TDMA is and what the concept about TDM is. So TDMA is an access method again in a data link layer. The data link layer in each station tells its physical layer to use the allocated time slot. So physical layer knows that this is the time slot on which I have to transmit the data. There is no physical multiplexer at the physical layer when we talk with regard to TDMA. But when I am talking with regard to TDM, that is time division multiplexing, it is a physical layer technique that combines data from slower channels and transmit them by using a faster channel. The brief introduction of what multiplexing is and what multiplexing techniques are, we have already covered. Now the process uses a physical multiplexer that interleaves data units from each channel. So when we say physical multiplexer, it is getting utilized at what? Your physical layer. When no multiple access techniques are employed and only multiplexing technique is employed. So that is what is with regard to time division multiple access.